Example 5 is saying use the given graph of y equals f prime of x. So this is the graph of f prime of x, not f of x. To identify the intervals where the function is increasing and decreasing, and the x-coordinates where you have local extrema. Then sketch a possible graph of the function. So it's backwards for what we did in example 4. So first what we want to do is use the graph of f prime to figure out where am I increasing and where am I decreasing. So recall in this example, these x-intercepts were places where my first derivative was equal to 0. And my first derivative is equal to 0 anywhere I have a horizontal tangent for my function. So if I look at f prime of x, I am equal to 0 at negative 2 and at positive 2. Those are my x-intercepts. So I have x-intercepts at x equals negative 2 and x equals positive 2. I also know that f prime of x lies above the x-axis or is positive from negative infinity to negative 2. It lies below the x-axis or is negative from negative 2 to positive 2. And it lies above the x-axis again from 2 to positive infinity. So what does that mean for us? That f of x is increasing from the intervals negative infinity to negative 2 and then from 2 to infinity, and f of x is decreasing on the intervals from negative 2 to positive 2. Why? Because anywhere the first derivative is greater than 0, your function is increasing. And anywhere that your first derivative is less than 0, your function is decreasing. So first it asks us to identify the intervals where f of x is increasing and decreasing, and then it wants us to find some local extrema. Well, let's think if this were on a number line real quick. And here's negative 2, here's positive 2. Well, if I am increasing and then decreasing and then increasing, do I have local extrema? Well, if you're increasing and then you're decreasing, you have a max. And if you're decreasing and then you're increasing, you have a min. So here, I'm going to have a local maximum at x equals negative 2, and I'm going to have a local minimum at x equals positive 2. So now it's asking us to finally sketch a possible graph of the function. Again, what do we know? We're going to have a local maximum at negative 2 and a local minimum at positive 2. So this value has to be a maximum and this value has to be a minimum. What else do we know? Well, we know that our function is increasing from negative infinity to negative 2, which means that it has to be going up from negative infinity to negative 2. And our function is then decreasing between negative 2 to positive 2. So our function has to be going down from negative 2 to positive 2. And then finally, our function is increasing again from 2 to positive infinity, which means it goes back up. So this is a possible graph of f of x. So given that first graph, f prime of x, we can look at the information from the graph and deduce what a possible graph of f of x would look like. Example 6 is saying, use the given information to figure out what the graph of f of x looks like. So first it tells us that the function is continuous over its entire domain. So that means we're going to have no jumps or breaks or asymptotes. Then it tells us that we have f of 0 equals 3, f of 2 equals negative 2, and f of 6 equals 6. Well, these are just ordered pairs. When x is 0, y is 3. When x is 2, y is negative 2. And when x is 6, y is positive 6. Then it tells us that f prime of 0 is equal to 0, and f prime of 6 is equal to 0. So that means that we're going to have a horizontal tangent at x equals 0 and x equals 6. It also tells us that we are not defined at f prime of 2, which means that we should have either a cusp or a vertical tangent at this point. And then it tells us right here the following. It tells us that our function is increasing since the first derivative is greater than 0 on the intervals from negative infinity to 0 and from 2 to 6. And then it tells us that our function is decreasing because the first derivative is less than 0 on the intervals from 0 to 2 and 6 to positive infinity. So again, we know that here f prime of 0 is equal to 0. Here f prime of 2 is not defined. F prime of 6 is equal to 0. So if we look at what's happening, here I am increasing and then I'm decreasing, so I should have a max at 0. This should be a maximum value. And then I'm decreasing and then I'm increasing, so this needs to be a min. So I have to have a minimum value at 2. So I said we either have a cusp or a vertical tangent. Well, recall, vertical tangents, you can't have local extrema with vertical tangents. So it has to be a cusp since we said it was going to be a min. So this is going to be a cusp at x equal 2. And then I go from increasing to decreasing, so I should have another max at this point 6, 6. So let's just draw this. Again, you're told you are increasing here, so I should be going up from left to right until I get to the point 0, 3. And then I'm decreasing. So decreasing until I get to the point 2, negative 2. Then I start increasing again, but recall it's got to look like a cusp until I get to the point 6, 6. And then I start decreasing again. So this is a possible graph of f. All right, number 7, the last one from this section, is asking us to find the intervals for which the function is increasing and decreasing, and then sketch the graph and add horizontal tangent lines. So it wants us to figure out where am I increasing and decreasing and sketch the graph of this function. So how do I do that if I'm given a function? We'll recall that's like examples 1 and 2. The first thing I need to do is find f prime of x. So the derivative here is going to be 3x squared plus 6x plus 3. Then I need to figure out where is this first derivative equal to 0 and where is the first derivative undefined. Well, this guy here is a quadratic, so there's nowhere where it's going to be undefined. So I just need to figure out where does it equal 0. So 3x squared plus 6x plus 3 equals 0. And then I might notice that every single one of these terms is divisible by 3. So I'm going to divide out my 3 before I factor. So I end up with x squared plus 2x plus 1 is equal to 0. Well, I know that this factors as x plus 1 times x plus 1. And then since these are the same, I only need to set it equal to 0 once. And I end up with x is equal to negative 1. So then I grab a number line and I put that partition number negative 1 on my number line. And then I choose a test value from every single one of the sections. So from negative infinity to negative 1, I'll choose negative 2. And from negative 1 to positive infinity, I'll choose 0. And I then need to figure out what is the value of the first derivative at negative 2 and what is the value of the first derivative at 0. So grabbing a calculator, I'm going to plug in the negative 2 into my first derivative. So 3 times negative 2 squared plus 6 times negative 2 plus 3. and I end up with a positive number, which means that in this interval I am increasing. Then let's find f prime of 0. So I would write 3 times 0 squared plus 6 times 0 plus 3, and I end up with 3. 3 is a positive number, so in this interval I am increasing. So I know that to answer the intervals for which the function is increasing and decreasing, that I know that f of x is increasing from the interval negative infinity to positive infinity because it's increasing everywhere, and f of x is decreasing nowhere. Then it's asking us to sketch the graph of f prime of x and draw in our horizontal tangents. Well, notice this does not have a max or a min because we're going from increasing to increasing some more. So I'm not going to have a maximum or a minimum, but let's go ahead and graph this. Well, what do we know? Well, again, we do know, and I'm going to write it down again because I've scrolled and I can't see it. But what we do know is, again, that number line that we have over there, that at -1, f prime of -1 is equal to 0, that I am increasing and then increasing some more. So f prime of x is greater than 0, or I'm increasing, and here f prime of x is greater than 0, or I'm increasing. So here, let's figure out where to put -1. Well, how do I find where to put -1? To find where to put -1, let's find the function's value at -1. Recall our function is this x cubed plus 3x squared plus 3x. So grab a calculator, let's figure out what that value is. So -1 to the third plus 3 times -1 squared plus 3 times -1. We get -1. So the value f of -1 is equal to -1. So let's put that point on here. So here is the point -1, -1. And then let's just draw the graph with what we know. Well, what do we know? We know that we are increasing until we get to -1, that we have to flatten out because we're going to have a horizontal tangent, and that then we start increasing some more. So this is the graph of f of x, and here is our horizontal tangent. And again, we have a horizontal tangent there because the value of the first derivative at -1 is equal to 0. That's it for section 4.1.